welcome everyone, and thank you for joining today's PotatoLink webinar, which is titled Future-Proofing Potato Production, Emissions, Resilience and Market Expectations. I'm Bonnie Dawson from Applied Horticultural Research, helping to manage the PotatoLink project, and I've been capably assisted by Azumi Kageyama, our graduate in our extension team. So thanks to Azumi for helping us pull together this webinar. And we're joined by Chris Cosgrove from Sustenance Asia, Marguerite Renouf from Lifecycles, and Dr. Tory Clarke from the Tasmanian Institute of Agriculture. I'd like to start by acknowledging that I'm currently on the traditional lands of the Gunai-Kurnai people, so I'm in Gippsland in Victoria, and that we're no doubt joining from many different diverse areas of the continent. I think it's valuable to recognise the long connection that traditional custodians have with the land that we work on and produce our food from, and the learnings we can take from this history. And I'd like to pay my respects to any elders past, present and emerging. So before we jump in, I'll just give a really quick overview of PotatoLink and why we're here. The PotatoLink project is the communication and extension project for the Australian potato industry. It's been led over the last 5 years or 5 and a bit years by AHR, Applied Horticultural Research, with funding through Hort Innovation using the fresh and processing potato levies and contributions from the Australian government. The project's delivered resources and activities covering a wide variety of topics as determined by the industry as much as possible. And it uses various comms and extension methods to satisfy different learning styles, primarily targeting growers and advisors, but also other stakeholders who are vital members of the industry. On this slide, there's a few photos. These are all from events that have been run in the first half of this year. So there's a drone demonstration night and a couple of soil health events over in South Australia. We put out a magazine and different written resources. And down in the bottom right, we've got a little reminder that we do have some very important events, namely in a couple of weeks, we've got the annual R&D forum coming up in Ballarat. So if you haven't registered for that yet, please consider doing so. And the resources are all available on the PotatoLink website, so feel free to head there and have a look at what's been developed over the past few years, including webinars, fact sheets, case studies, podcasts, and don't forget to sign up for the quarterly PotatoLink magazine and monthly bulletin. And of course, we have some social media channels on LinkedIn and Facebook, so follow those as well. Just some quick housekeeping. So we're using Teams here. Hopefully it's functioning all right for everyone. We are recording today's webinar so that we can pop that on the website for people to watch back. Questions can be put in the Q&A function. Please don't be shy, ask those as we go along, and we'll have a dedicated Q&A section at the end of the webinar. And we'll also at the very end have a quick survey which will really help us work out what to do next and whether today was valuable, whether you've got further questions that you want to explore on the topic, etc. So just quickly, the objective of this webinar is to help potato growers understand and navigate the evolving emissions reporting landscape. We hope that you can take away practical insights into the benefits and opportunities that come from monitoring and reporting emissions, how to do so as simply as possible, and where efforts are best focused in the paddock for genuine efficiency gains. So yeah, we'll get started. Our first presenter, who it's a great privilege to introduce, is Chris Cosgrove of Sustenance Asia. Chris was recommended to us by the Australian Fresh Produce Alliance as one of Australia's most experienced agri-food sustainability practitioners. He has been involved in corporate sustainability since 2002 and has specialised in agri-food sustainability since 2014, delivering pragmatic outcomes for clients in most of Australia's agricultural industries. He's particularly focused on collaboration and making complex sustainability concepts simple and actionable. Chris has developed a common approach to greenhouse gas accounting for the AFPA and is a reference group member of the Australian Government project to develop a common approach across agriculture. He's currently working with the AFPA, that's the Australian Fresh Produce Alliance, to help its members reduce time and cost needed to meet their mandatory climate-related disclosures. And we're very grateful for his time and willingness to share some of this with the potato industry today. So over to you, Chris. Thank you. Stop sharing. Hey, let you in.
Thanks very much, Bonnie, and g'day everyone. It's lovely to be here. Excuse me. When I talk to farmers and others in agriculture about sustainability, I normally hear two things. One, sheer confusion at what sustainability is. And secondly, I guess skepticism that it's more of a cost exercise that's being imposed on them in a box ticking exercise that just wastes time and money rather than something that adds value. After 25 years working in sustainability, I understand why people feel that. Because it's become incredibly noisy, the sustainability landscape. My job with clients is to cut through that noise. That's what I do. I work to help agri-food businesses understand what really matters in that landscape, which noise they can safely block out, and how they can take a pragmatic approach to manage what matters rather than just ticking boxes. And that's what I hope to do for you today. I'm going to just start with a broad helicopter view of what sustainability is and how greenhouse gas accounting and reporting fits in that sustainability landscape. And I hope that then sets the scene for Marguerite and Tory to delve into more details in greenhouse gases, but also I hope it gives you an insight into the fact that sustainability can actually add value rather than just be box ticking. The reason why it adds value is that it should be a really simple process to manage risks and opportunities, and specifically managing environmental, social, and economic opportunities. That's important because all of you who run businesses, you're all aware of typically financial risks and the obvious risks and opportunities, but sustainability says look outside your business. Think about the impacts you have on the environment, on the natural capital you rely on to run your business and how it impacts you. Think about how you impact society and how society and reputation and perceptions of people can impact you. Think about how you impact the economy, particularly the local economy, and how that impacts you. When you think about that, then it becomes more obvious about the value of sustainability. And how sustainability is managed, it's not just picking out things out of the air or ticking boxes or tree hugging. There's a really specific global methodology for managing sustainability that has the three boxes you can see in the how column there. Starting with monitoring risks and opportunities, and importantly, doing that by, again, looking outside your business, talking to your customers, to your suppliers, to the people who you rely on, reading what's happening in government policy and technology changes and environmental changes, in market changes, to work out what are the risks and opportunities you can see, prioritize what matters, manage what matters, and then measure your progress. So a really systematic, simple process, to manage risks and opportunities. And if you follow that through, then the value becomes pretty compelling, and the value is always the same, regardless of whether you're a bank or a mine or a farm. There's always 3 or 4 drivers of value. If we look just at greenhouse gases in climate, because that's the focus of today's webinar, the first value driver is risk and opportunity management. If you regularly and methodically look outside your business at those potential changes, not just for what's happening in the next year around your weather, but what's happening in 30, 50, 70 years' time in terms of climate changes, what are the political, the technology, the social impacts you can see resulting from that, then you should be more alert to and able to manage risks and opportunities coming up. One of the ways to reduce your greenhouse gas emissions is to be more efficient with your inputs. If you're a potato farm, that's typically losing less nitrogen and using less fuel. So if you do that, you're more productive, but also you're reducing your greenhouse gas emissions per unit of output. One way to reduce your greenhouse gas emissions, and particularly nitrogen, is to improve your soil health through practices that give your soil better food and shelter, be that rotations or cover crops or other practices. By doing that, you improve the resilience of your soil to climate and other shocks. And so that reduces the risk that you have from that critical asset that is important to all farms. And finally, the fourth value driver is market access. We all know that increasingly companies are looking for, and in many cases are legally required to talk about their greenhouse gas emissions along their value chain, and that will become the same for other aspects of sustainability. You can expect to see more and more demands to meet markets, to access markets around environmental, social, and economic impacts. So sustainability, in my view, is simple. It should be simple, and the value should be pretty compelling. The reason why people are so confused is because of this. Now, this is just a snapshot, just a few of the many standards and frameworks and guidelines and acronyms that are out there. I've kindly grouped them into some headings, which they aren't normally grouped in the wild. They're out there confusing everyone, roaming around randomly. You don't need to know all of these. It doesn't hurt to be aware of them, but the good news is you don't need to know the detail of any of them. And for the purposes of today, all you need to know are two things. One is that there is, in all this alphabet soup, a common global standard for measuring or accounting for greenhouse gases, the Greenhouse Gas Protocol. And there is a key reason for why companies are increasingly asking for greenhouse gas emissions data right now, which is the AASB, or the Australian Accounting Standards Board S2 standard, otherwise known as climate-related disclosures, mandatory climate-related disclosures, which companies of a certain size have to report. Okay, it doesn't hurt to be aware of other stuff that's in this ecosystem, if you like. It doesn't hurt to be aware that the reason that all this work is happening is because most countries around the world have signed legally binding treaties under the Paris Agreement to limit emissions in the atmosphere. It doesn't hurt to be aware that many large companies around the world, potentially some of the people on the call now, but certainly the big retailers who you supply to, or the banks that you're looking to get money off, are setting targets for greenhouse gas reductions around using the science-based targets methodology. It doesn't hurt to be aware of that and other stuff. But for the purposes of today, all you need to know is there is a clear, common approach to measure greenhouse gases and a clear process for reporting climate impacts. And that's what we're going to focus on in the next few minutes. Before we get to that, I'll just touch briefly on another source of confusion, though, which is Scope 1, 2, and 3 emissions, which are just a fancy way of defining where exactly in the value chain emissions are released relevant to your business. If you're a business that does activities that produces greenhouse gas emissions directly from your operations, those are your Scope 1 emissions. So if you're a potato farm, you have two sorts of Scope 1 emissions: mechanical, so burning fuel in trucks or tractors or pumps or sheds that you own. They're directly producing a potato, involved in producing potatoes. They're owned by you. They're your Scope 1 mechanical emissions. You also have Scope 2 non-mechanical, which is typically soil, either from nitrogen naturally in the soil or being added by nitrogen fertilizer, creating nitrous oxide, which is a greenhouse gas, or by crop residue, biomass degrading and releasing greenhouse gas emissions as well. So any farm that grows potatoes has its own equipment, puts fertilizer, has biomass growing and dying, will release Scope 1 emissions. Scope 2 emissions are always the energy you purchase, and normally the electricity you purchase from fossil fuels. So if you're using electricity in your packing shed, for example, that's your Scope 2 emissions. You'd be glad to know, if you're like me and have teenagers, it doesn't include the emissions from electricity in your house, so it's just the business-related emissions. Of course, if you run your packing shed or other operations on your farm purely by renewable energy, or if you're based here in Tassie, where I am, where all the electricity is renewable energy, then your Scope 2 emissions are zero. Scope 3 emissions are the emissions that happen before stuff gets to you that you need to run your business, or what happens to your product after it leaves your farm. So in the case of potato farms and most cropping systems, by far the biggest upstream, in other words, the thing that happens before you get there, is the energy it takes to manufacture nitrogen fertilizer. It's a very energy intensive process, and there's a lot of emissions associated with that. Unless, again, there's emissions, there's fertilizer factories located in somewhere like Tassie where there's all renewable. There isn't, but if there was, that'd be zero emissions. And the emissions taken to burn fuel and stuff to get those fertilizers or pesticides or goods to your farm. They're your upstream Scope 3 emissions. Downstream Scope 3 emissions are what happens, the emissions released from getting your potatoes to market. So the trucks, the transport, getting it, and what happens getting it to processors and to retailers and to consumers. So that's your scope 1, 2, and 3 emissions if you're a farm. Because scope 1, 2, and 3 varies depending on where you are, you can also just apply the same logic to if you're a processor. If you're a processor, the scope 1 emissions are what happens, assuming you own your own trucks to get potatoes from a farm and to the retailer. Your scope 1 emissions are the diesel burnt in those trucks, or the petrol burnt in your equipment, or the energy used in your manufacturing facility. Your scope 2 are the purchased electricity. Scope 3 emissions are what happens again downstream or upstream from you. Downstream, there aren't many because you're just looking at what happens to potatoes in the retail and in the consumer, which isn't much. But upstream, there's a lot of emissions, and most of them happen on the farm, which is why there's so much interest in agribusiness right now of getting of big companies getting their scope 3 emissions, i.e. their farm emissions, their upstream farm emissions. Why are they looking to do that? Well, because they have to in many cases. So it's now mandated, it's by law required of companies that are of a certain size and are very, very big to start providing this AASB S2, which is what I referred to earlier on the earlier slide, the Australian Accounting Standards Board S2. It's called a sustainability disclosure, but that's confusing again, because really it's just a climate disclosure. It's about climate-related impacts to big companies, not to be confused with AASB S1, which is sustainability more broadly. Again, there's confusion everywhere. But AASB S2 asks companies that are really, really big last year, this year companies that are pretty big, and next year companies that are big to provide a climate-related disclosure. So there's clear size thresholds for who needs to report. Most family farms won't need to report unless you're really, really big. It's something like $50 million gross revenue or $25 million of assets that you need to be a threshold, or 100 employees to have to report. But what you can see here is that a couple of interesting things. One is that companies need to report 4 different things: their governance processes for managing climate risks, the risks and opportunities and how they identify them now and in the future around climate risks, their strategy for managing them, and their metrics and targets. So there's a whole heap of things that companies need to report, and greenhouse gas emissions, which is what everyone focuses on, is just one part of one section of the report. If you look at climate-related disclosures coming out now, you'll see there's a lot of content being given to risks and opportunities and strategy in particular. Greenhouse gas emissions are actually only one small part of it. But companies do need to report, and they do need to report their scope 1, 2, and 3 emissions. So if there's a processor on the call who has to report, provide climate disclosures, or someone else or someone further up the chain, they need to report their own emissions, scope 1 and 2, but also their upstream. So remember, most of that comes from what's happening on farms, which is why they're so interested in scope 3 emissions. How do they do that? How do they account for that? Again, all you need to know is there is a global methodology, or global standard, I should say, for doing this, called the Greenhouse Gas Protocol, which the mandatory climate-related disclosures require companies to follow. Again, you don't need to know the detail of this. As Bonnie mentioned, I've worked with the Australian Fresh Produce Alliance to create a common approach for their 11 horticulture members. The Greenhouse Gas Protocol is effectively 10 chapters, really detailed, and there's different decisions you can make on each chapter. We sat the 11 AFPM members around a board table and just worked through how we decided together, each of those 10 chapters, what will everyone agree to do the same. So that's what we've done there. It's available online if companies are interested and want to look at it, but it's focused on farm production. Again, you just need to know that's there. You don't need to know about the detail. What's important then is, how do companies measure their scope 1, 2, and 3 emissions if they have to? And they have 2 options if they're needing to report under climate disclosures. One, they can say, well, I'm a processor, I source potatoes from 100 farms. That's too hard to measure all of them individually. I'll just use an industry average. And that's when Marguerite, who's speaking up to me, her work comes in. She will have an industry average. I've worked out an industry average. Average potato production releases 1 kilo of carbon dioxide equivalent for 1 kilo of potatoes, or whatever it is. Okay, and I'll just multiply that, if you're a processor, multiply that by how many tons of potatoes you buy. That's how you do it. Companies will be able to get away with that possibly in the first year or 2 of reporting, but not for much longer than that. They will be expected to measure emissions from each farm. And how they do that, we've looked at this in this common approach for AFPA, is to use the same tool. There's a lot of different tools out there to help calculate or estimate greenhouse gas emissions. These 11 members of the AFPA and pretty much every other agriculture sector in Australia, cotton, beef, grains, others, all using what's called the GAF tools, GAF, the Greenhouse Accounting Framework, developed by a guy called Rich Eckhart, who's the greenhouse gas guru for Australian agriculture at the University of Melbourne. In this case, it's H-GAF, Horticulture GAF. You've got B-GAF for beef, D-GAF for dairy, etc., etc. So in future, or perhaps even now, processors who want to calculate the Scope 3 emissions of the 100 or so farms can use H-GAF or some other tool they want, but the common approach normally would be to use H-GAF. And they can take two approaches to do that. One is to get the activity data from those 100 farms and aggregate all those 100 farms up in their head office and calculate it. Activity data is the stuff you need to know to calculate what your emissions are. Or they can give H-GAF to their 100 farms and say, here, you use this, calculate your emissions, and send them back to us and we'll aggregate from there. There's no right or wrong answer, but I suspect for most companies, getting activity data from farms and putting it into a single spreadsheet will be their easiest way to do it. I'll just wrap up by just highlighting that whilst all this can be complicated and it can seem complex, it doesn't have to be. And when you look at even calculating greenhouse gas emissions, the H-GAF tool is really, really simple. The screenshot of the spreadsheet is there on the right. If you haven't seen H-GAF and you go to open it up on the website, it's a massive spreadsheet, and you'll say, bloody hell, who was that red-headed fella? He was lying to me. It's really messy. It's not. There's no need to stress. All you need to worry about is the second tab on this spreadsheet, which is data inputs. And in that, all you need to put is literally a handful of data inputs. You need to say where your farm is and how big it is, what's your production and yield, and then what are the things that produce emissions on your farm? Your fuel, your pesticides, your herbicides, and your electricity. From that, it automatically calculates your Scope 1 and 2 emissions. Sorry, Scope 1 and upstream. Upstream, Scope 3 emissions. So fertilizer, manufacturing, that sort of stuff. So it's not hard. It's not as hard as it is often made out to be, at least anyway. What is different is that farmers will increasingly need to keep that evidence, whether that's sales records or purchase records or invoices, which they already have anyway in most cases for accounting or for their accountants. It's just a matter of keeping them and providing them as evidence for their value chain. So that's me. I hope that's given you a quick introduction to sustainability that, yes, I know it's complicated, but it shouldn't have to be. And it can be an opportunity, not an obligation. Thanks, guys.
Thanks so much, Chris. That was, I think, really powerful in showing that it doesn't, like you say, it doesn't have to be complicated, even though there's a lot of information there. Now, while Marguerite gets her slides up, I will just introduce her quickly. Marguerite Renouf of Lifecycles has 20 years of experience in sustainability assessment in both academia and consulting, specialising in environmental life cycle assessments, or LCAs as they can be known. She is an authority on agricultural life cycle analysis in Australia with a long track record working with agriculture, food and bioproduct sectors. And we're grateful for the knowledge that she'll be sharing with us today and through the Lifecycles project that she'll describe. Marguerite's a senior scientist and head of business development at Lifecycles, Australia's leading sustainability management consultancy, which is based in Melbourne, but she's working out of her office in Brisbane. And thanks for joining us here today, Marguerite.
Thank you. I've shared my screens. Are you seeing it? Great. Thanks, everybody, and thank you for the introduction, Chris. As Chris mentioned, I will continue the story by going, I guess, another level of detail to talk about a project, a Hort Innovations project that is a first step in setting up the potato industry with the metrics for greenhouse gas emissions that Chris alluded to, and the first step in a journey of understanding risks and opportunities for potatoes and what your priority actions might be. The title of the project is an industry level life cycle assessment. It hasn't got greenhouse gas emissions in the title, but because we are in this project looking at more indicators than greenhouse gas emissions, so we're looking at a few other environmental aspects using the same whole of life cycle accounting approach, which underpins greenhouse gas accounting. So just a slightly different scope, but today I'll be focusing on some of the early results we have had for the greenhouse gas emissions. So we're about halfway through the project, so we're just sort of giving you some insights. I'll quickly talk about the scope of the project as a whole. What are some of the numbers that we've got so far? And probably most importantly, what some of those early numbers tell us in terms of what hotspots and reduction priorities might be, and how you might benefit from the project's findings. The project is ongoing as well, and we are engaging with growers. And if you want to be involved, there's still time to get involved. And at the end, I'll give you a link you can follow. I'd really like to acknowledge other people involved in this project who have helped us greatly. Of course, Hort Innovations, which are funding the project out of the processing and fresh funds. We have a great active project reference group. We've been working with some participating growers who've been helping us understanding the differences across the industry, what we should be looking for, gathering data from them to give an early snapshot. And of course, industry sector associations that have been helping connect us with growers. The aim is to generate some science-based sustainability indicators for Australian potato industry. You'll see I've got a list there of the indicators that we're looking at. And in the final report for this project, in about a year's time, there will be results for all those metrics in there, presented as industry averages. But we'll be talking just today about the greenhouse. We're halfway through the project. We started off by getting a sense of what studies were already out there and what sort of greenhouse gas emissions intensities are being reported for potatoes in the literature. And then we did a deep dive into Australian potato production specifically with some case study growers, modelling their systems fairly comprehensively, and understanding what are the variables in the industry that seem to influence the number at the end of the day. Chris mentioned the H-GAF tool, which is a very useful tool for starting on greenhouse gas accounting. We didn't use the GAF tool for this project, but we used a software model that effectively makes the same assumptions and does the same calculations as the GAF tool, but we do it a little bit more comprehensively, and it gives us an opportunity to play around with different variables. After we finish the case study phase, we'll expand our sample and get a bit more data to generate robust industry average values, and then the final report will give some meaning to those numbers in terms of what does this mean moving forward for priority initiatives, target setting, and also to feed what we learn in this project into improving tools that people will use, such as a GAF tool. This is to show you the scope of the potato system that we're looking at. Within the blue box here are the steps in the potato supply chain that we're including. At this stage, the results I'll be showing you today will be for potatoes ex-harvest, so potatoes at the farm gate. We are also gathering data about post-harvest treatment, different packaging, grading systems, etc., and then delivery onto the various endpoints of the different types of potatoes. That work is still coming. By the end of the project, we will have greenhouse gas intensity results for potatoes ex-harvest, potatoes at the pack house door if relevant, and then potatoes delivered to their endpoint. So we will be able to generate a set of numbers at different points in the supply chain to suit different purposes. Within the potato growing system, of course, most of the data that Chris referred to that you would collect if you're using the GAF tool, for instance, is sort of in this potato growing box. We also acknowledge that seed potatoes are an input, how to have a separate process, and of course upstream from that is mini tuber. So we actually went right back and accounted for the mini tuber production going into seed production and then going into potato production. And you can see I've got over the left all the various inputs that we're interested in that have greenhouse gas emissions associated with them. And these bubbles represent the places where we typically see the greenhouse gas emissions coming from. Many of them are carbon dioxide, fossil carbon dioxide from burning fossil fuels, but we also account for nitrous oxide, which is caused by the denitrification of nitrogen fertilizers. Sometimes there can be methane from dams, not a great deal, but we also capture as much as we can to get as much of a comprehensive picture as we can. So let's get straight into the early results that we have. So this is an average result from the sample of case studies that we've looked at so far, and they are ex-harvest, so at the farm gate. Just over to the right, I'll just explain our sample. We aim to have a sample, eventually an industry sample that is representative, that sort of aims to capture production in different states, perhaps slightly different production systems, etc. But for this initial deep dive, we've been very fortunate to work with 7 growers across the main areas. To give us a bit of a picture, we have so the data, the result represents a sample containing 6 processing growers and 1 fresh grower. When we move forward to get a larger sample, we're really hoping to get more data into our sample for fresh production, and we're making some progress on that. So over to the left is how we've represented the results at this stage as kilograms of CO2 equivalent per kilogram of potatoes ex-harvest. So that captures both the whole sample, processing and fresh. So it doesn't these don't differentiate between those two at the moment, but we do anticipate that we might think there's value, or it's warranted to have a separate benchmark value for processing potatoes versus fresh potatoes. We're not sure yet, but we'll see what pans out. So the first thing to mention, I haven't actually given a number as yet. We're still working with ranges. It's still too early in the project to sort of give you where we've landed. But from our current sample, I can show you on the graph that we've got a range. We can also compare what we've calculated with what we're seeing in other published studies from other international studies, which is a broader range. But at least we can see that the numbers we're coming up with are within what's been reported elsewhere. So there's no surprises. We're not producing anything for Australian potatoes that's different to what we're seeing elsewhere. The other important thing to look at is the various aspects or activities. Chris referred to activity data, so the things that are generating the activities that are generating the emissions that we're interested in counting. And we call this a contribution analysis, which helps us work out where the hotspots are, where are the things that we could be focusing on. And as Chris already alluded to, very typically of agricultural crops, fertiliser use, both the production of fertilisers upstream as a scope 3 input to the farm, and then the subsequent emissions of nitrous oxide when those fertilisers are applied. That's the 2 green. So the green sections is related to fertiliser, its production and its use. The other one that Chris also acknowledged is energy, both fuel, so diesel or petrol, and electricity. Our samples seem to suggest that both electricity and diesel are used. and from one farm to the next you see some differences depending on what their energy split is. But at the moment, an average towards quite a bit of diesel and some electricity. We also account for the upstream production of pest control agents that come to the farm. Typically, it's quite small, and that's also the case for potatoes. And we also account for the transport of the inputs to the farm, so the distance that materials travel from where they're produced right through to the farm, which again is important to account for. It's part of the equation, but it's typically moderate. The other thing we account for is upstream production of mini tubers and seed potatoes, which again is really just part of the potato production system. We've just highlighted that when it's amortized over your entire farm's potato production, it's still relatively small. So that's the profile that we're getting, and it tells us that we're within expected ranges. Thinking of what Chris referred to, that we often also talk about emissions in terms of scope 1, scope 2 and scope 3. So I've just rearranged the graph a little bit in a way that allows us to compartmentalise that into scope 1 emissions, which are the ones that occur on the farm, which the grower has control over, on-farm fuel use, so emissions from the fuel use, and the emissions from the nitrogen fertiliser. Scope 2 is the emissions upstream from production of electricity, and then, as Chris alluded to, a reasonably big chunk of scope 3, which is other people producing on your behalf, fertilisers, lime, pest control agents, etc., that come to your farm. So that's a fairly typical split for most agricultural crops. Moving forward, the other thing we can start to take away from this information is if organisations were interested in reducing their emissions, so managing their risk, looking for opportunities, then we can see that fertilisers is an important hotspot, and energy is the other important hotspot, and the others are perhaps less of a priority. So they are the main contributors. For fertiliser use, of course, it's the manufacturer, which growers don't really have much control over, except if they've got choices of what sort of fertiliser they can produce, that they can purchase. We asked, work that's happening is starting to differentiate the greenhouse gas emissions intensity of fertilisers produced in different regions. For example, urea produced in Canada versus China versus Arab Emirates, for example. We are starting to differentiate, and more you might be able to get information about the differences in the scope 3 emissions of the fertilisers you purchase. But of course, on the farm, you do have a degree of control over the emissions released from the fertilisers, which we'll talk about a little bit in the next slide, I think. And then energy combustion on your farm is something that you can focus on. The others are less significant. There are a few other things we're still determining. There's downstream transport of product is still coming. Packaging will come in the latter stages. We found that the key influencing factors is irrigation, energy for pumping water, the emissions intensity of the state in which you're producing. Different states have different emission intensities for electricity, and it wouldn't be of any surprise that nitrogen use efficiency is also important in this context.
Marguerite,
yes?
Sorry, just jump in quickly and just give you a couple of minutes longer. If that's
thank you.
All right, yeah, cool, thanks.
Yeah, this should be my last slide. Thank you, Bonnie.
Thank you.
I wanted to put these numbers in perspective. When we see a number, it's often hard to tell, is that big, is that small, is that good, is that bad? So it isn't until we start to be able to compare that we can tell. Now, at the end of this project, we'll have industry benchmarks and we'll have industry ranges, so growers will be able to calculate their own values and then check how they're going against the industry. So that is of some use. It's also some use to see how potatoes compare across other food groups, and this is there's some growing work published that compiles emission intensities of different foods, and we can see that root vegetables have inherently very low emissions intensities. So in the scheme of things, potatoes already come as low emissions, and I guess that has an advantage in that anyone wanting to move towards net zero perhaps has more chance of doing that in this sector than perhaps in others. The benefits of this is the industry will have some numbers to move forward with. You will have some expectation of what emission reductions you might be able to achieve. As Chris mentioned, environmental efficiency also translates to economic efficiency. They work hand in hand. And this project will tell you what some of your priority opportunities for the industry are. We have got the second half of the project to go. We're interested in expanding our data samples, so particularly for producers of fresh potatoes, we would still love to hear from any growers that would like to get involved. And here's a QR code that take you to a link where you can get some more information and register your interest from us. Other parts, the final parts of the projects will work out recommendations for the industry, not only in terms of reduction opportunity priorities, but also for what improvements could be made to the GAF tool to make it a robust tool moving forward. Thank you very much, Bonnie. That's me.
Thanks, Marguerite. And yeah, sorry to give you a hurry along.
Understand.
It was a great content that you just delivered, and I think you gave a really good overview of how there are a couple of different methods going on, but they're both really important to have our head around what it means for the industry, and yeah, the power of your project to give that overview of where the potato industry sits. So our next presenter is Dr. Tory Clarke, and Tory will hopefully be able to give an illustration of how it all comes together on farm and the different, as Marguerite highlighted, the hotspots that are worth focusing on. So Tory's a crop physiologist and senior research fellow at the Tasmanian Institute of Agriculture. Her research applies crop physiology to practical challenges in horticulture, helping improve productivity, sustainability and resilience in commercial production systems. She works closely with growers and industry to develop evidence-based strategies that support better crop and environmental outcomes, including at the Forthside Research Farm in Tasmania. Tory currently leads a field-based research program, which we'll hear about, measuring greenhouse gas emissions from cool climate vegetable production systems, including potatoes. This work is building the evidence base needed for benchmarking nitrous oxide emissions, improved nitrogen use management, and lower emissions production strategies in horticulture. Her research supports growers and industry to identify practical ways to reduce on-farm nitrous oxide emissions while maintaining productive cropping systems. Thanks, Tory.
Thanks, Bonnie. Yeah, so I am going to talk a little bit about a project that we've been working on down in Tassie. So I'm based in northwest Tasmania in Burnie, and we have our research farm nearby at Forthside. And this project has been running for about a year. So like Marguerite, we're just getting some early data, but I wanted to share the results, I guess, from our season one and what we're finding out so far in this project. So just a little bit about the research farm for those who might not have had the chance to visit yet. It's based, northwest Tassie. We're a cool climate region, and primarily for horticulture in this area, it's an annual crop rotation. And so that's vegetables and also some extractives often included in that rotation, things like pyrethrum and poppies in Tasmania. And at the research farm, we've set up what we're calling a demonstration farm, where we're following a kind of typical vegetable crop rotation and looking at what the emissions are from that production system. So this project is funded by the state government, and it's running over 4 years, and we're looking, I guess, across 4 main crops, including potato, which is what I'm going to talk about today. And the goal of this project, firstly, is to understand what the nitrous oxide emissions are from the production systems that we have here in Tasmania, and at the same time also evaluate what opportunities we have to reduce those emissions while still meeting the same yield and quality metrics in the system. And as part of this, we're working with the state government, also doing an economic analysis for the return on investment. So what does it actually cost to produce the potatoes? What are your margins there? And what is the equivalent return on investment for any changes that you might make towards lowering emissions? And we've worked with a range of different industry partners in this project, and working with them for the different crops within the system so that we can replicate, I guess, what we're calling like a typical management program might be for that particular crop, and then working with them to also identify what strategies could we implement now that might help us reduce emissions in this system. So the trial design is split into 4 blocks, and each of those blocks will have a different crop in it each year, and over the 4 years we rotate through it. So I'm just showing the design for our first year of the trial, which we've just completed over the last summer, and we had potatoes in block 4. And so those 2 kind of treatments that I talked about, I'm going to, just for simplicity, I've got the labels here of what we're calling our conventional manage. So this is optimised for production. So this is sort of our best, most efficient, management practice for each crop. And then what I call the optimised, this is really around optimising for emissions reduction. And so we're looking at strategies that we can implement now. So this is more about practical things that are available rather than, developing new technologies or new fertilisers. We're looking at, with the tools that we already have and what we already understand about the relationship between fertiliser and emissions for nitrous oxide, what could we implement now? And so we're calling that our optimised emissions management strategy. And so the main things that we're doing in that program that are different from what you might typically do in a production system is we're really looking at what opportunities we have to really link nitrogen fertiliser application to demand in the plant. And so opportunities to improve the efficiency of the nitrogen use that we're using. And so that might be using a little bit less nitrogen. It might also be looking at when we apply the nitrogen so it better aligns with crop demand. And also the form, what type of fertiliser we're using, how available that is to the plant, whether that's a solid or whether we're looking at fertigation opportunities. And then because we're looking at this across the rotation, we've obviously got our spring cash cropping time, but in between that, we've got this opportunity as well to look at, what cover cropping and green manure opportunities might provide for supplying nitrogen into that system. So this is just some photos from earlier in the year, back in February, and you can see down at the bottom of the block here, the potatoes are growing. Above them was where we had the peas, and so we just pulled the peas out and prepared the beds ready for broccoli. And I've just got some close-up photos showing, the potatoes as they were growing in about February. And I've also put some numbers on here around the nitrogen inputs. So overall, we used about 25% less nitrogen in our optimised emissions management program. And we were able to achieve an equivalent yield. It's actually slightly higher, but not significantly different. I've just put percentages there. We are trying to manage this as we would a commercial farm, but obviously it's still a research trial, and so we're doing smaller plot harvests, and there's a little bit of differences there. Typical yields would be about 60 tonnes a hectare, and ours were in that range. But I'm just expressing them here as percentages, just to show that, I guess our aim was, with whatever we're doing in terms of managing emissions, what we want to make sure is that we're not having a yield or quality impact on the production. We still want to hit exactly the same production, if not more. And so for the potatoes, we were able to achieve equivalent yield. I haven't put the data on here, but we had a range of quality metrics, and all across all of the things that we were able to measure, we didn't see any differences between our management program. So as Chris mentioned, the H-GAF tool can be used to estimate what the emissions are. And so for our first season, as we're establishing what our management programs are, we decided to take all of that data and put it into H-GAF and look at what our emissions impacts would be. And so, yeah, as Chris said, it's quite simple. What you need to know is, what your nitrogen inputs were, and that gets broken down by whether it's urea or not urea. Potassium and phosphate as well go in there. If there's liming, pesticides, other products that you put in, you can add them all in. Your electricity use, which for us in our project was primarily around irrigation, so we pump water with electricity. And then your diesel use, so driving the tractor to apply the fertiliser and do the other parts of the processing. And I've done the calculations here, just scaled up for a 40 hectare field size. Obviously we had a smaller area than that, but we've calculated and measured everything on a per hectare scale, so we can just scale that up. And then the numbers I put here, so again, this is just one season of data, and I'm not sure if you remember the numbers that Marguerite just put up, but we're sort of in the low end of that ballpark. I think she sort of had numbers from about 0.10 to 0.20 for the emissions intensity. So this is the carbon dioxide equivalent greenhouse gas emissions for our system, and this is to the farm gate. So we're not accounting for any processing or transporting after that. So what we're particularly interested in is the scope 1 emissions in this project. So these are the things that a grower has a bit more influence on. So looking at how much nitrogen and fuel and electricity you're using on your farm as part of producing the crop. And so on the left here, I've got this hotspot analysis where you can see the breakdown of the different contributions to the overall emissions amount. And so down the bottom, there's a blue wedge there for nitrous oxide emissions, which you can see in our optimised management program. We have reduced that a little bit. It's not a huge difference. We used about 25% less fertiliser, but we didn't get a 25% reduction in our overall emissions from this. And that's primarily because a lot of our emissions are coming from the diesel use, right? And we're still having to apply fertiliser, we're still driving the tractor, we're still pumping water. In Tasmania, there's very little emissions for the electricity, so that's not a big contributor. But you can see as well for the fertiliser in green there, and this is the production and transport of the fertiliser to the farm. Because we've used less fertiliser, we do have less emissions associated with that. And then on the right-hand side, I've just broken this down just in the scope 1. So these are the on-farm emissions. And you can see we do have a small reduction there in nitrous oxide emissions as predicted using the H-GAF tool. But what we are doing in this project to move this forward is we are also going to be looking at actually measuring those nitrous oxide emissions. So we've used the calculator and put in all that information, and this is based on a lot of data that's gone into these models, but they are very, generalised models. And so for us, we see it's a really valuable opportunity to actually look at what the emissions are in our systems in Tasmania. Tasmania being cooler temperature, often a lot of these microbial processes will happen at different rates. So the nitrification and denitrification in the soil, the microbes that are doing that are going to be working at different efficiencies at different temperatures. And so we're really interested to look at what impact that will actually have. So we're moving into the next season of our project now, and you can see that we've just come out, we're sitting at July now, so we've got some different cover cropping treatments in where we're comparing either a fallow, which might typically happen, or looking at if we actually put a green manure in there, what the impact of that will be. And yeah, as I mentioned, a key thing in this project is actually going to be measuring the emissions. And so I just wanted to highlight Kate and Indu here working with me on the project. Kate's a tech officer based out of the research farm at Forsyth, and Indu's recently joined us for her PhD. And there's a picture of me here with some fancy new tech that we've just got at TIA. So the Institute has invested in an in-field nitrous oxide analyzer. So this is a machine that we can take into the field, and we can actually measure the fluxes of nitrous oxide. So we can then cross-validate this back to what our predictions are and actually look at the impact of the different management programs that we're evaluating on nitrous oxide emissions. And then that data will then be really valuable to help improve tools like the H-GAF going forward as well. So just it's useful for us in our research, but it's also going to be something that just improves the quality and robustness of those tools that you'll be able to use to predict emissions on your own farms. So that's all I was going to say. I've just put a link here. We've got a website for the project. At the moment, most of our work is focused on what we're doing at Foresight, at the research farm. So if you are in Tasmania, please reach out, come and visit us. We'd love to give you a tour. But going forward in the project, we'll also be supporting growers that want to try some of the management practices that we've evaluated and look at what their impacts might be on their own farms. So we're very keen to talk to any growers that might be interested in learning more about what they might be able to do towards reducing emissions in their systems. Thank you.
Thanks so much, Tory. It's a great overview and yeah, really cool to see a good, robust way of putting what we've heard into practice. We've just got a couple of minutes left until 1:30 and I'm keen to finish on time so you can all go about your plans for the day. But there are a couple of questions in the chat, so I'll just read these out and perhaps our presenters can jump in with if you think you're the best to answer. How does the estimated carbon footprint of potatoes at the farmer's gate differ between the LCA approach and the H-GAF tool? And I know we did have a bit of a discussion about this. So Marguerite or Chris or Tory, any of you, so I'm just kind of throwing it open.
Yeah, Bonnie, I just popped a bit of an answer in the chat just
Oh,
then.
so you did. Thanks.
Yeah, we haven't actually done the test to actually see exactly what the difference is for potatoes, but we've done something similar for other hort crops. There are some fairly minor differences in terms of what's included. I mean, the LCA tends to be a little bit comprehensive, being able to take into account some things which are typically considered insignificant, like the production of irrigation infrastructure, the production of farm infrastructure. We account separately for the production of mini tubers and seed potatoes, which may or may not be sort of captured. Things like methane emissions from dams. All of the things that are different are usually quite minor things, and in the GAF tool it's meant to be a simplified tool, and rightly so. They would sort of not include things which are typically insignificant, whereas we would try and capture them to be comprehensive. But the main difference I think I've observed is within the GAF tool there are some assumed scope 3 emissions intensity factors, so assumptions about what the greenhouse gas emissions intensity of the fertilisers and the pesticides, the transport are. The GAF tool has, I think, original versions of it drew some values from literature, which have been traditionally a little bit outdated. It's not to say they're wrong, whereas in the LCA tool we have a large databases to draw on, databases that are regularly being updated. So we are using different emission factors, scope 3 emission factors. So there are some differences there, but those are actually being resolved over time. Our group's working quite closely with the GAF developers to generate for them consistent sets of scope 3 emission factors, so that hopefully everyone is using eventually the same scope 3 emission factors, and so that the number you get from the LCA and the number that you get from GAF should eventually over time become consistent.
Thanks, Marguerite. And I'll go from one Marguerite to another. Marguerite White's put in the chat asking Tory what you believe are the shortcomings of using the GAF tool for a Tasmanian rotation crop system. For example, what are some of the managements that growers use that are not accounted for?
Yeah, I mean, I think when we do, like even using the GAF tool, you're doing it kind of per crop. And so I've talked today just about what we found in potato, but we're growing things in a rotation, and what you do in one crop is going to influence, the soil nitrogen that's available for the next crop. And I don't think that's I haven't, like in using the tool, I haven't seen a way to build that in yet. And it's really complex. So I think that's why it's not there yet. But I think we have an opportunity to link that in. I mean, the key thing that we're doing differently is the timing of the nitrogen application. And so we're doing a lot of sap and tissue testing and looking at actually plant use and demand so that we can really align that. But in the GAF tool, you just put everything in together. So your total nitrogen, it doesn't account for, you know, how you've spread that out across the season. And we're going to be able to get some data around that to actually understand what the differences are in terms of if you're putting a lot on at once or you're spreading it out, because that's going to influence, you know, that flux of nitrous oxide. So I think that's something that, you know, going forward, hopefully can be better predicted with the GAF tool.
Thank you for that. I'm really conscious of time, and we do have a very quick poll that Azumi is going to pop up just to get your feedback on today and hopefully the value you gained from it. This will really help us with our planning going forward, as well as, of course, the good old reporting back to our funders. But yes, if there's any final questions or comments, please feel free to continue adding them to the chat, and we can perhaps respond with an email if there's anything that's, to continue the conversation. But yeah, otherwise, thank you very much for attending, and thank you immensely to our presenters, who were all very complimentary of each other. It was a great mix, and hopefully you've taken out a lot from today's session.